project for EEL6825 pattern recognition, and the topic of my project is hand gesture recognition in virtual reality control. So the problem statement. How do we achieve this kind of hand detection and hand gesture recognition? The most accurate approach for hand detection is through gloves with sensors that can sense the joints and fingers of humans. However, this approach is not simple enough to implement it in daily life. If we want to exploit the hand gesture recognition in daily life, it requires another easy to implement approach without extra device. So the reason why we choose web camera to detect the background and segment the background from foreground is that web camera is one of the most normal devices that modern laptops and desktops are equipped with. So the solution to the problem. The most applicable approach obviously is to exploit the web camera on laptop, combined with some machine learning processes and image processing techniques to detect hand in real time. There are three main techniques to detect hand gesture. The first one is background subtraction. Using this approach, all of the static views in frames are treated as background. Only hands in motion are detected as foreground. Problem for this approach is that this algorithm is background dependent, which means that the background needs to be relatively static. The second approach is segmentation based on object color. For this approach, color pixels are detected and abstracted. So here we need a threshold for the color to adapt the color of human skin. Problem for this approach is that if there is some kind of object with color close to skin color, then the result might be inaccurate. The third approach is edge detection. This approach can be very imprecise without implementing background subtraction or color segmentation. So the edge detection needs to be combined with background subtraction or segmentation based on object's color, based on the two approaches above. So let's talk about the background subtractions. There are two types of background subtraction technique. The first one is real-time frame detection, and the second one is background scene modeling approach. For the real-time detection, it takes the method of frames differentiation to identify the background and foreground. It records 3 frames at a time and compares the difference of pixel values among these 3 frames. For background modeling, it is adapted to changeable background scene. It is more accurate than real-time frame detection. The background modeling first takes several frames as training data for a specific model. More training data will provide more stable background frame identification. After background model has been constructed, the segmentation between background scene and foreground scene will be performed. Then moving object can be detected. So what about the background scene modeling? First, we take different number of frames as training data, calculate it, and record the mean value of each pixel and the covariance of different frames pixel value, and modeling the background frame and match it to Gaussian mixture model, which is most frequently used model for background detection. Here is the set of results for background scene modeling. We calculate the multivariate normal distribution of these two sets of continuous background frames and draw the scatter plot of them. Let's do scatter plots on the right side show the background frame distribution. We take the mean value and covariance of those frames and fit that into multivariate normal distribution. Sorry. Here is also a set of background scene modeling results. This is the result after modeling this kind of background scene to Gaussian mixture model. When we have achieved the background multivariate distribution, we may match the distribution to Gaussian mixture model to construct the model of background frame. The right side of the figure shows the probability density function of background frames. After we have constructed the background frames model, we can segment the background frame and the foreground frame in different windows. Here, the background scene is relatively static while the hand is moving in front of the web camera, so that the web camera can detect the hands moving and hand gesture. As you can say, the image above it shows the background scene, and the image below shows the foreground scene, which is the shape of my hand. After we have segmented the background and the foreground, we may introduce some kind of image processing approach to the foreground image in order to achieve the best segmentation result. It is because that the web camera itself may introducing some kind of noise, so we have to denoise the original image and create some better output. As you can say, the image above shows the original foreground frame before the image processing. The photo below here shows the frame after the image after the image processing. Here we use the image dilation and erosion to perform processing on foreground frames. This process can denoise the original image and create better quality image for detect. So the last step is to detect the hand shape. We draw the contour of detected hand and draw the convex hull of the detected object, and then we use the defect detection class to detect the defect shown in the convex hull and draw the circles on it to track its coordinates and to figure out the position of the finger. As you can say, this is a screenshot of this program, and you can say, on the top of my each finger there is a small circle which shows which tracks the top of my 5 fingers. So the conclusion of this project exploits the Gaussian mixture model to model the background frame. Then segment the background frame and the foreground frame. The Gaussian mixture model can be perfectly used in background detection and modeling, while enough training data has been taken into consideration. Yet here, model needs to be retrained if background frame changed a lot. And that is the slides presentation. And after this presentation, I will show you a little demo of this hand gesture detection. Here, as you can see on the screen, is the source code for the hand gesture detection, and it is written in C++ and using the OpenCV library for hand detection. Here I'm gonna firstly make this, and after that we can open this program. Here you can say, sorry, I opened two of them. Here there are three windows showing different part. This is the foreground. This is the extracted background. Here, as you can say, it is saying background extracting, please hold, which means that it is now detecting the background and modeling the background. After this disappear, we can say this is the foreground and this is the background frame. Here, if I use my hand here, it will detect my hand. And sorry, here I can also move my hand, and you can say here on the top of the screen it is the coordinates of my hand, and this is the number of defects of the inside this convex hull, and this is the foreground image, foreground frame. When I move my hand, it shows a little noise here because it is used the web camera, and the background is still here. So I can here use different hand gestures such as 1, 2, 3, 4, and 5. It can detect my hand, detect the end point of each finger, move my hand, and it can track the coordinates of the end point of my finger.